Okay, welcome. This is the last webinar of the whole class. So thanks for coming. Thanks for watching, those who are watching this on recorded. So let me talk about the plan today in terms of how we're finishing the class. And that is, as always, I'll start out with Q&A. So any questions you might have, I'll be always happy to answer them throughout the whole time. And then we're going to get into the very last hypothesis test of the quarter, and that is called ANOVA. And we'll see the details, have an example. It's pretty much used in research, and that you'll only see it in research, but it is in research. So we'll talk about ANOVA, and it's used a lot in research. And we're only going to do the beginnings of ANOVA. This is an elementary statistics class, not an advanced statistics class. So we can't do some of the advanced parts of ANOVA, but we'll do some stuff. We'll talk about the requirements that you need to be able to do ANOVA. Some you're used to, and some will be somewhat a little bit new. Okay, and we're just going to talk about the requirements. We're not going to talk about, for some of the requirements, how you can decide if they're actually met or not, but at least we can, understand them. And then project 2 is due by Sunday, and the hope is in the next day or so, you send me your draft, and then I can take a look at your draft and give you comments. If you've already sent it, thanks a lot. Then I've already given comments, and I'll talk about just the project. I'll take Q&A on the project. There's some things that you might want to think about. So that is the plan for the day. Are there any questions? Any questions? Anyone, feel free to pop in the chat box or wherever. Okay, if there are any questions, I want to let you know this is going to be possibly the shortest webinar of the quarter, because we just have one chapter to work with. We don't go into the really tough details, but we talk about a hypothesis test, and it's not one of the harder weeks that way, because one reason is that the project's due on Sunday, so you should be spending a lot of time on the project. So I kind of made it an easy week in terms of work to do. So that's just a big note. So let's think about it. We've had a lot of different kinds of hypothesis tests. Can you give me some examples where we don't know how to conduct a hypothesis test yet? There's a bunch, but one of them is the one we're going to do today. So we've done a hypothesis test. What we started, our first one was a single population mean, then a single population proportion. Remember that? Yeah, we have not done a hypothesis test comparing standard deviations. It turns out that I used to actually, and I realized it wasn't used that much, so I stopped doing that one. So we don't do it, and I realize that most other colleges do not compare two standard deviations in the elementary stats class, so I dropped it. So we don't do that. Multiple population tests. What kind of populations are you talking about? Because actually chi-squared can do some multiple. Yeah, more than one variable. Chi-squared does more than one variable. But there's something specific about the more than one variable that chi-squared doesn't do. Okay, and by the way, a test for two independent means or two dependent means, that's more than one also. Yeah, so we did a test for to compare two means. Do you remember that?
Mm-hmm.
So we have done comparing two means. What haven't we done yet? You don't really compare confidence intervals. I don't think I've never heard anyone wanting to do that. It could be done, but it's no one's interested. Yeah, so more is what if you want to compare three means? Or what if you want to compare 100 means? So we only know up to two, and we want to be able to handle more than two. And that's what the last chapter of the book is how do you do a hypothesis test to compare many means. Okay, it might be something like, is there a difference in the population mean weight of people by state? Okay, by the way, how many means would you be comparing? Yeah, there's 50 states in the United States, and you'd have to compare all 50 of them. Does that make sense?
Um,
Okay. Yeah, if you count territories, but I said the word state, so no. That's only if it was states or territories. But since it just said states. So one thing you could think about doing is we can compare, let's say, California, New York. And then we compare Nevada to New Jersey. And then you can compare Oklahoma to Alaska. And you just compare all the different states. And if none of them, if you're not able to reject any of the hypotheses, then hey, there's no difference, or there may not be any difference. If you are able to reject a hypothesis, then you found statistically significant evidence that there's a difference. So not all the states are the same. What's wrong with what I just said? There's actually something very wrong with it.
yeah.
Takes too long. Actually, it doesn't take too long because we have computers nowadays. So you could do that by putting in a computer, and I could code the computer to do it for you, for example. So that's no big deal. There's actually something specifically wrong in terms of statistically wrong with what I just said. Let's suppose you used a 5% level of significance for each of them. What's the problem? Okay, I don't see it. So let me tell you the problem with doing that. It turns out that if you looked at every pair of states in the United States, there's thousands of pairs. Does that make sense? It's actually 50 times 25, but 51 times 25, but I won't get into the reason. But there's a lot of pairs. And if each time you tested, you had a 5% chance of a type 1 error if you used a 0.05 level significance on each, and you did it for thousands of times, you're going to get type 1 errors, and you're going to eventually just say, hey, they're different. You're always going to say they're different, even if they're the same. And that's not okay. Does that make sense? So you got to be very careful about doing many, many, many hypothesis tests and saying if one of them shows significance, then we have a conclusion. The problem is if you do 100 hypothesis tests with a 5% level of significance and they were all wrong, then 5 of them are going to say that you were right. Does that make sense? So it's pretty intense. So it turns out what you need to do is you need to do a different test that kind of puts it all together. And again, the last thing I'm going to do in this class is get into the mathematics of it. But there's some deep math in putting it all together and making it so that you really do have only a 5% chance of falsely rejecting the null hypothesis if the null hypothesis is true. And that's what you want. And it's called ANOVA. So the first thing, and this is really confusing, is ANOVA stands for analysis of variance. Okay, it stands for analysis of variance. So the reason why this is confusing is this going to be a test to see if the means are not all the same. And it's not to see if the variances differ. It's to see if the means are not all the same. The reason why it's called analysis of variance is too mathematically deep for me to get into. So I'm not even going to go there. But in terms of, the purpose of it is to analyze means, not variances. Okay, the variances in the math deep inside, which I'm not going to do. Okay. So everybody I've ever heard of just says ANOVA. No one says analysis of variance. They all say ANOVA. That's less confusing than analysis of variance because then you don't think about variance. Okay, so it's called ANOVA. And it tests to see if several means are equal or not. Okay. Variance isn't the opposite of mean. Remember, variance is the square of the standard deviation. I don't know if you remember that. That happened in like the first week of class. So it's the square of the standard deviation. So it's definitely not the opposite of a mean. It's not take the mean and multiply -1. That wouldn't be it. We skipped any use of the variances. I mentioned it, and that's about it. Yeah, so we did skip how it's used because it's only used for math, basically. So in this, even though this is called analysis of variance, don't even think about variance, we're thinking about means. And it turns out there's a null and alternative hypothesis. And the way I strongly recommend it is to write the first one, and I require the first one has to be written in symbols. And that's H naught colon mu sub 1 equals mu sub 2 equals, if it was looking at the example of, states in the United States, saying the weight being the same, you don't have to write mu sub 1 equals mu sub 2 equals mu sub 3 equals mu sub 4 and just write down all 50 of them, because it'd take forever. So if there's a whole lot, you write ... equals mu sub 50, and if it was a states idea. If it was just, say, maybe 4 different means, if you wanted to find out, I don't know, how about 3 different means? Do students do better in terms of percent on their final in fall? Is there a difference in the amount, how students do on their final in the fall, winter, or spring quarters? And then you would just write mu F equals mu W equals mu S. Does that make sense? So if there are just 3 of them, just write down the 3 or even 4 or 5. But after that, usually use the ... notation. Any questions on how to read and write this H1 and H naught? Any questions? Okay, H1 I used to do in symbols, and I gave up when I realized that most of the class couldn't do it. So I went to words on this one because it just I gave up. And in words, so this is something really important. If you think that H naught is mu1 equals mu2, let's say it was, mu1, mu2, mu3, and mu4, right? Let's say H naught was mu1 equals mu2 equals mu3 equals mu4. Could you write that H1 was mu1 not equal to mu2, not equal to mu3, not equal to mu4? What's the issue with that? What's the problem with that one? There's actually it's just wrong, and there's a reason why it's wrong. Yeah, some may be equal and some may be different. And if, say, there were 2 pairs and the 2 pairs were equal to each other, but then the first pair wasn't the same as the second pair, then you wouldn't have that all of the means are different. You would have the first and the fourth were different, even though the first and the second were the same. Do you see how that works? So the way you state that in words is at least 2 of the population means differ from each other. ANOVA is the first tool, and you pair it down with hypothesis testing. No. ANOVA is what we're doing. ANOVA is a hypothesis test.
So
if you wanted to decide which pair was different, then and I said this last week too, then you go to a university and take another statistics course that's of upper division level so that you can learn about some more tests that do that kind of stuff. Sound good? So if ANOVA is just to see, are they all the same, right? That's a null hypothesis. And the alternative, at least 2 are different. And that's all you can say. You can't say that which 2, or they're all different, or some are different, some are not different. You don't know which ones. Does that make sense?
Yeah.
Yeah, so, and again, I can't get into the details beyond that because, again, that would be another statistics class that you could take. Okay, which you may someday. I don't know what your plans are in graduate school or undergrad or whatever, but not in this class, since this is our last day of new material. Yeah, you tend to do two. It turns out there's two tests, but I'm not going to get into the other test because we can only do so much. And I've never met any faculty at any community college that ever does the other tests. So I don't. And I go to conferences to check in with them to make sure that I'm doing the right stuff, that we're all kind of together. And I'm kind of one of the big statewide leaders, so they all listen to me now. It's a little weird. Okay, so now comes the requirements. If you remember when we did a regular hypothesis test, let's just say for a mean, if we just did, the chapter 9 hypothesis test, where you did a hypothesis test, you just had, hey, mu is 7 is H naught, and mu is greater than 7 for H1. What requirements did you have to do that test? There were a couple. Do you remember? Yeah, the sample size had to be greater than 30, or you had to have a normal distribution to start with. Do you remember? Yeah, and it didn't have to be simple random sampling, but it has to be unbiased. Yeah, it didn't have to be simple random. If you do a good stratified sampling that's not biased, then that's fine. Does that make sense? So the key is make sure you don't have bias. All right, well, it turns out we're gonna need that, we're gonna need even more to do ANOVA. So let me go and show you the requirements to be able to conduct an ANOVA test. And they're the following, there's 5 of them. The first is instead of the sampling distribution, the one I just gave you is normal, you have to make sure that every single sampling distribution, because remember, you're testing the mean of many things. So for example, in the, weight of people in the states in America being the same versus not all the same, then you'd have to show that the weights in the sampling distribution of weights for your California people are normal. So are your Texans. So are your, Kansas people. And so is your Vermont people. Do you see? Water testing in Lake Tahoe has to use ANOVA. All depends what they're testing. If they're just testing, Lake Tahoe to see if the average, if let's say the average pH is greater than 7, then you don't do ANOVA. Depth of clarity. So that would probably be a confidence interval for depth of clarity. Because you're going to be testing a bunch of, do a lot of tests, on different days of the year. And then you're going to come up with a confidence interval for how clear it is. It's not really a hypothesis test, right? Unless your hypothesis is that it's worse than last year, and then it would be it could be a 2-sample t-test, right? If it was this year versus last year, and you just have a sample for both. So it really depends what you're doing. Yeah, it really depends. On the other hand, if they were looking at the turbidity in each of the many creeks that flow into Tahoe to see if there's a difference, that would be ANOVA, because it's not just 2 creeks anymore. There's many creeks that flow into Tahoe. Does that make sense?
Yeah.
Yeah, so it truly depends on what, there are so many hypothesis tests done on Lake Tahoe, just to let you know that. They do everything, they do chi-squared, independence, they do all kinds of stuff. Okay, they test for regression analysis, all kinds of things. Okay, so just let me continue on the requirements. So you have to have a normal distribution. Here's one that we have not had to deal with before, and that is all of the population standard deviations must be equal or close to equal is good enough. Okay, and again, I can't get into any details on why you have to have that. I also cannot explain how you decide if the standard deviations are equal, because that would be an upper division hypothesis test. So as I mentioned, we're only going to be doing the basics of ANOVA. We're not going to do any of the big details. Okay. Number 3 is, we already mentioned that one for the others, but pretty much every test you ever do for any hypothesis test, you better have no bias. Okay. If you're completely biased, then no, that would be ridiculous, right? Okay. Does that make sense? Okay. You also have to have independent samples. Okay. So usually that's not that hard to do, but you just have to make sure. What you can't do, for example, is ask 35 people 7 questions to see if their answers are different. If the answers to each of the 7 questions are all the same, because that would be the same person answering 7 questions. Does that make sense? That'd be the one case where ANOVA wouldn't be done. And again, if they're dependent, as I mentioned, we're going to be pretty much saying for this whole class, is you enroll in an upper division statistics class and you learn how to test. And there's a different test for that one. So there are statistical analyses for pretty much anything you'd ever want to do, but many of them are upper division or beyond. Okay. In fact, there was even one where I did some consulting work for the Forest Service, and they wanted something, and I just researched. I didn't find any statistical analysis, so I made my own mathematically. I didn't make anything up, but I created my own. So basically, you can create new ones too, as long as they're mathematically correct. So you have to have independent samples. And then the last one is the samples were consistently taken. Okay. So that would be, for example, if you looked at the weight of everyone in America, and let's say you weighed people at the end of December in Alabama, you weighed people in July in California, you weighed people in September in New York, etc. What would be wrong with that? And then you looked at the mean weight for each of the states and said, hey, there's a difference. What's wrong with it? Yeah, the time of year matters, it turns out. I don't know, you may not know this, but do you know when people are the fattest? Yep, right after the holidays. That's why I said end of December. That's when they're fat, because they tend to eat a lot at the parties, and drink too, eat and drink a lot. So that would be a poor test because you're not consistently taking the samples, because you're only doing July in California. So, even if California and Alabama were the same, which they're not, by the way, then you would show California, would be lighter because that was summertime. Do you see how that works? So the other thing is you have to make sure that the way you ask or conduct the research is the same too. And I think I mentioned one of my first company job was at a market research company. And what they did to make sure that they were consistently taken is there were a whole bunch of people that would collect the data, and we'd have a meeting. Okay. And again, this was way long ago, so we actually met in person in a room and we talked about it. And we said, this is what you should ask. And if they have these questions, this is how you respond to the questions. And we wanted to make sure that in each location at which we did the survey, we all did it in the same way. Does that make sense? Nowadays you do a Zoom meeting, but that didn't happen in the 70s. Okay, so any questions on what it means for the samples to be consistently taken? Okay, So again, the one that we don't really have any clue on how to do is number 2. All you have to do is know to state that that is a requirement. Okay, sometimes an assumption. Any questions so far? All right, let's do an example. Okay, so let me make this a little bigger font. Okay, suppose that a study was done to analyze the racial differences for the distance in miles that people live from the nearest public library. I don't know if you ever thought about that, but it'll kind of be important. The data from the study are shown below. Okay, and so you can see they surveyed people who are white, Black, Hispanic, and other. Any questions so far? Okay, and you can see that, there was this person, this white person who lived 15 miles from the nearest library. Here's a Black person who lived real close, 1 mile away. Okay, I live 2 miles away, by the way, from the nearest library. So, I don't know where y'all live, but everyone has a different mileage, possibly, from the nearest public library. So we're gonna have to decide what we're gonna have to assume, and we're gonna have to assume all kinds of things. So let's go and look at what we're gonna have to assume. That's a good first step, is what are the requirements, what are the assumptions we have to make? Okay, so one is we're gonna have to assume that all 4 distributions of distance from the nearest public library are approximately normally distributed. Why do we have to assume that? Yeah, less than 30. Okay, and by the way, yeah, less than 31. That's even better. And by the way, and that's each of them needs to be greater than 30. And so if we, for example, surveyed 35 Hispanics, but only 4 Blacks, then you wouldn't have to assume the Hispanic distribution is normal, but you would have to assume the Black distribution is normal. Does that make sense? Any questions on that? Okay, in this case, because all of the sample sizes are small, we're going to have to assume that the whites distribution of distance from the library is normal. The Black distribution of distance from the library is normal. The Hispanic distribution of distance from the library is normal. And the other distribution of distance from the library is normal. Does that make sense? And that's because all of these are less than 31. Is that clear? Okay, so we have to assume that they're all approximately normally distributed. By the way, do you think this is a good assumption? No, it's a terrible assumption. So I want to give you, especially since this is our last day, I want to give you a heads up. Just because I do it doesn't mean it's the right thing to do. Okay, you should never assume that you have a normal distribution. What should you do instead in the real world? For a study like this? Yeah, you would make sure that you get a samples so that you have over 30 whites, over 30 Blacks, over 30 Hispanics, and over 30 others. Do you see that? Okay, so why am I not doing that for this example? Yeah, simplicity, this is a class. I'm not doing any research. Okay, I don't really care if this is, and in fact, if you look at the first word was suppose, you know what that really means? If I write suppose, do you know what that means? Yeah, it just means that I just made up these numbers. Okay, and that's even worse, by the way. In the real world, you do a survey and you make sure you have all that. So I want to get you ready for leaving this class and realizing what you should take with you and what you should not take with you. Do not take with you, oh, well, most of the sample size are small and that was fine. That's not fine. It's only fine for an example in a class or an exam question kind of thing. just so I don't have to do as much typing, basically. Okay, so that's just a big note. Okay. Do we need to assume all population standard deviations are equal? Yes, yes. There is no reason to believe that they're equal. Okay, so that is definitely an assumption we have to make. Okay, simple random sample, no bias. Again, nowhere in here did I say how the study was done, which means it needs to be assumed. Okay, sometimes you can do a good study so you don't have any significant bias, and that is usually doing a multiple stratified sample, and that could cut most of the bias, and then you're good. So that is something you can do in the real world. But again, this isn't the real world, this is just a class. Any questions on that? Okay. The samples are all independent, probably not a problem. Why is it probably not a problem for this particular study? Anyone see? It's not that you can't be two races, but yeah, it's not likely that we paired up this first white person and this first black person and the first Hispanic person and the first other person and did like kind of pairs like that. That'd be like really hard to do anyway. Why would you want to? Does that make sense?
Yeah.
You probably just went around asking people and then they're independent. Do you see how that works?
Yeah.
Yeah, it's not independent if you go and, let's say we only looked at, couples where the, husband was white and the wife was black, then that would be dependent, but that'd be hard to do anyway. Why would you do that for this test? Do you see that? Yeah, well, twins can't happen. Yeah, definitely not identical twins. You can't have different race identical twins. Okay. But you can have couples, that's for sure. Okay. So the samples were independent. Again, probably not an issue that it'd be hard to make them dependent, in fact. Okay, and then the samples were consistently taken. That's also probably true. It may not be. It may not be true. And when can you think of an example where this study could be done where the samples are not consistently taken? Different states, kind of, maybe. That one's kind of like pretty vague though. I want specific where it's really clearly not consistent. Should I tell you? Okay, let's suppose we went to a black neighborhood that was a small town that had a library right in the middle of the town. And then we went to a white neighborhood that was a much larger town that only had one library. Do you see that? Then it wouldn't be a consistently taken study. Do you see how that works? Yeah, one state has less libraries. That isn't the issue actually, because for example, I can guarantee that say Vermont has fewer libraries than California. But why does Vermont have fewer libraries than California? Or even better, Rhode Island. Let's go Rhode Island. I can guarantee Rhode Island has fewer libraries than California. Yeah, in a day, I could walk across Rhode Island. But I'm a big hiker. You may not be able to do that. But the point is, there's a huge difference in size. Do you see that? So the density of libraries makes, the density of libraries and how many of each race live in that area. Yeah, a combination of the two. Does that make sense?
Mm.
So again, there may or may not be issues with that. That one's an easier one to deal with than the standard deviations being equal or simple random sample. Those are really hard. Any questions at all on the requirements needed? Okay, so the next step is the hypotheses. So first thing, the test we're using is ANOVA. Hopefully that's clear because we have a survey that is quantitative and we have 4 different populations and we're comparing the population mean for the 4 populations to see if they're all the same or if there's differences. Do you see that? And that's what ANOVA is all about. Any questions on that? Okay, so then H naught, I'm going to write mu sub W equals mu sub B equals mu sub H equals mu sub O for white, black, Hispanic, and other. Okay, if you can make it kind of pertain to the population in terms of the symbolism, that it's better than 1, 2, 3, and 4. Does that make sense? It's much clearer what these means represent than if you just went 1, 2, 3, or 4. And then H1 is at least 2 races have different population mean distances from the nearest public library. Okay, so just note, population mean needs to be there. This is about population means. Okay, I definitely, have noticed in your exam, for example, a lot of you did not write down that you were referring to the population, and that is important. At least 2, that's important also. So it's not that they're all different, it's that at least 2 of the races are different. Does that make sense? Also, you should refer to the public library because that's what this is about, distance from the public library. Any questions on H naught and H1? All right, what do you think the next step is? Yeah, we're going to go to a calculator, okay? And by the way, usually you decide on level of significance. This is standard stuff, so you probably use 0.05. Okay, so we're going to go to our calculator. And I got some good news for you. What calculator do we use? 25. Why is that good news? Yeah, we're done. This is the last topic of the entire course. Okay, there are no other topics. There's no other statistics to deal with. There's no other hypothesis tests. We're done. It isn't multiple calc. Oh, there's vector calculus, but that wouldn't be that would be a whole different thing. That wouldn't be statistics at all. It isn't a mathematics-based statistics class. Maybe that's what you meant. So I'm going to ANOVA. And the way I wrote it is enter the data separated by commas, and then everything will be calculated for you. So our data is 15 for 11. Nine, 3, 2. And then 12, 1, 6, 6.
Mm.
Then 9, 17, 5. Then 14, 7, 1. And 18, 11, 2, 8. By the way, one of my internship jobs while I was in college, that's what I did all day long is type numbers. Not for math, by the way. AT&T, actually. So I'm actually pretty good at typing numbers with commas. It's a really boring job. And hey, calculate. And what do you notice? First thing, this is a different letter. We've never seen this guy before. F. So it turns out the ANOVA uses what's called the F distribution. Okay? We've had a lot of distributions in this class, right? We've had the binomial distribution, we've had a normal distribution, had the uniform distribution, we've had the student's t distribution, we've had the chi-square distribution. Remember all these different distributions we've had? And the very last one of the course is the F distribution. Here's the picture of the F distribution. Okay, it's also a little like the chi-squared is that there's only a right-hand side. You can't do a two-tailed test. Doesn't make any sense to do a two-tailed test. There's not even a second tail. And you do a right-tailed test. Any questions in the picture? It turns out, I don't get into the details, but there's different degrees of freedom for the test, which I'm not going to get into. In the old days, we had to, but now we have calculators. So I just want to let you know if you ever hear that, then it's part of ANOVA, part of the F distribution, where you have two different distributions, different degrees of freedom. Our p-value is about 0.8. Okay, and that's a big p-value. So the good news is hypothesis testing is hypothesis testing. Okay, you see a p-value like 0.8, you should know what to do. What do you do when you see a p-value like 0.8? You give up, but what's the fancy statistics way of saying I give up? Yeah, we failed to reject the null hypothesis. And you state there is insufficient or statistically insignificant evidence. Do you remember doing that for every chapter of this in the last like five chapters or so? Okay. So our p-value is 0.8 and our f was 0.33 about. Name of the test is ANOVA. Level significance, we're going to use 0.05 because it's standard, and this is kind of standard. F was 0.33, that's our test statistic. P-value is 0.8. Okay. So just to note, this is a study about that sociology kind of study, right? So sociologists pretty much always use 0.05. Just let you know that. So you don't have to think about the level of significance. It's going to be 0.05. Any questions at all on putting it in the calculator and understanding how to read the test statistic and the p-value? Okay. And just a reminder, because it happens in every chapter, here's our number 0.3339. It's really close to the, kind of the edge of the F. It's not like in the very shady area. If you look at the area to the left, you're going to get 0.8. That's what it means to have a p-value of 0.8. It means the area to the left of 0.3339 is 0.8. Any questions on that? Okay, and I have these marked on if you used a 10% level of significance, a 5% or a 1%, and we're not even close to any of them. We're far left. So it's very clear we failed to reject, even if you weren't given a level of significance. In the real world, you often aren't given a level of significance. You look at this and you just say, we have no evidence. It's such a big p-value. No one would ever use anything close to 0.8. Is that clear? All right, so then conclusion. There is statistically statistically insignificant evidence to make a conclusion that, and I can just copy and paste H1. One good thing about an online class is everything you do is a computer anyway, so copy and paste is always allowed. Okay, that at least 2 races have different population mean distances from the nearest public library. Remember, statistically insignificant evidence means you don't know that's true or not. Doesn't mean that everyone's at the same distance. It just means, you know, what's a likely thing besides everyone's at the same distance? What's another reason why we might have gotten a p-value of 0.8? Any thoughts? Most aren't the same distance. If they were really different distances, you get a really small p-value, right? But what's a reason why we might not have gotten a very small p-value? Yeah, small sample size. Look, we only surveyed 4 people that are Black and 4 people that are other races. And even white and Hispanic was only 6 people. Okay. Promise me if you ever do a study that's important, don't do a sample size of 4. Okay. Don't even think about it. Okay. I want to make sure that you come up and, you know, realize that you need big sample sizes. And I want to let you know, I had a student come to my office. It was like, I think 3 years after the student took my class. They were getting their master's degree. They were real close to their, you know, thesis. And they had a sample size that was really small. And I had to give them the hard truth. You have nothing statistically if you have such a small sample size. This assumption is stupid. You can't do it. Does that make sense? Okay, so promise me that in the real world, if a master's thesis, for example, if you have to do a study, do not do a sample size of 4. It's never okay. It was 2 or 3. Yeah, it was just a few. It was, yeah, I don't remember the exact size, but it was like really stupidly small. And the student was in tears because at that point, the student remembered what you need. Okay. If you had 25, that's still kind of too small, but not quite as bad. But 4 is never okay. Not to do any statistics on. So, and I want to let you know, I'm not sure if I mentioned this to you, but after this class is over, let's say you're, you know, taking a course in, you know, upper division psychology and you want some stats help. I'll be happy to help you if you drop me an email. You know, but I might give you the bad news that your sample size is too small. So, you know, just because I'm happy to help you doesn't mean you'll be happy. It just means you're going to be informed of statistics. So I'll be happy. And if you graduate and then start a business and want to do it for your business, remember what I said the cost is if I help you? If you're doing it for your business? Yeah, donation of the college for a scholarship. Okay, that's all I ask for. You don't pay me, you give a scholarship. And I've done that a bunch of times too. Okay, I want to mention one more way of doing the conclusion that you'll see in publications. And that is there is statistically insignificant evidence that starts the same to make a conclusion that race is a factor in the distance from the nearest public library. That's another way of saying the same thing as at least 2 population mean distances from the public library are different by race. Sometimes they'll use race as a factor, and that means exactly the same thing. So I wanted to give you a heads up on that's another way of writing it. Any questions on that? Okay, so what I'm going to do is I'm going to give you the secret word, and then we'll talk about the project. So the secret word for today. And this is the very last secret word of the whole class. And that is thank you. Because I want to thank you for having a good attitude, asking, positive questions when you had questions, and especially for you who've been coming. Yeah, this is 2 words. Sorry. I didn't mean to like double the pain, but maybe I should have wrote thanks. I don't know. Thank you is what I put. Okay. So the secret word is thank you, because again, thank you for your, being good students, and, I really hope you do well. What I want to do now is talk about the project. So I want to remind you, now I can go to the syllabus, is we've now seen the very last statistics in the elementary statistics class. Isn't that kind of cool?
Yep.
The project and also the calendar is important too. So the project must be submitted by the 24th of March. Okay. And I recommend submitting on the 23rd. That way, if something happens on the 24th, you're not screwed. A day early isn't that big. So it must be submitted by the 24th of March, and that is Sunday, by the way. And again, I think I mentioned already, but when you send me the rough draft, it has to be sent by Thursday at 8 a.m. And if you send it, at 7:59 a.m., it might take me a while to read it and stuff, because then I'm going to read everyone else's first. So I read it by how they come in. So if you're the last one, if you send it in at 7:59 a.m. on Thursday, I may have 5 to read, and it takes me hours to read through these. So it might be Friday or Saturday before I can get back to you. So I strongly recommend don't wait till the very last minute, because it might take me some time. And I do have a lot of time on Thursday, but it takes a lot of time to read through these and write comments, because some of these projects are very long. So that's just a note. And then there is the project discussion board, project 2 discussion board, and that's something you can post any questions you have. I only read one draft, but I'll read whatever comments or questions you have on the project discussion board, however many you have, so that you can keep asking. But don't like post your whole project and then say, can you read it again? Because no, that doesn't happen. But I will answer questions. The tutors will also, help you with it too. That's a big note, is the tutors are here for you, and they want to help. I talked to a couple of them yesterday, actually, and they'd love to help you out. So that is important. Also, I strongly recommend taking a look at the project discussion board and looking what other people's questions that they posted and my comments, and it'll give you an idea of things that you have to do. Okay? Because if you have questions, you should post on the board, not email me. And then everyone can benefit from understanding the statistics that's required in the project discussion board. The only things you'd email me about is like if you and your partner are having a big fight and you need me to like talk to you together or something. Hopefully that doesn't happen, but the point is only personal stuff. And usually just about everything can be done in the project discussion board. Your rough draft, though, gets submitted. That one gets emailed to me, okay, or messaged to me, whatever you want to call it. And then your final submission gets put in Canvas, just like Project 1 did. Does that make sense in terms of how that works?
Mhm.
And I want to remind you that throughout the entire paper, you're writing about the decisions the client will make based on these pieces. Okay, and the 3 main things are the standard error, the confidence interval, and the hypothesis test. And for the confidence interval, remember, the lower bound needs to be analyzed, the upper bound needs to be analyzed. Okay, don't just write it in one sentence. Full analysis in what the client will do based on the lower bound, full analysis based on what the client will do on the upper bound. Okay, because they're gonna be different. So it's just a few things that a lot of people have difficulty with. That's why I want to point them out. Okay. Any questions you might have about the project? Any questions? Okay. I do want to mention one more thing on the calendar. And that probably if I go to home, as soon as it scrolls to it, there we go. Okay, we are in week 11 right now. So project 2 is due on the 24th. Your concluding discussion. Okay, if you do not get a 10 out of 10 on the concluding discussion, you weren't paying attention, okay? Just do it on time, okay? It's the easiest discussion post there is, just let you know that. Do not do it late. Don't wait till after Thursday to post your initial post, and make sure you do reply to your classmate. This is the easiest one there is, okay? Just want to let you know. Okay, you can have a secret word quiz. Wait, there's a question, just a minute. How do you apply decisions regarding the upper and lower bounds? Okay, well, the lower bound, so the idea is that if the mean difference was the lower bound, what would the client decide? If the mean distance difference was the upper bound, what would the client decide? Does that make sense? Okay. And you could say that, hey, the lower bound is like so low that the client, or maybe not that low, that the client doesn't have to worry much because only lower than that would be a problem. Do you see? Or maybe the lower bound is a problem, and then the client has to make a decision. Do you see? And same idea for the upper bound. Okay, so hopefully that answers the question about your about the lower and upper bound. I want to mention something about the secret word quiz. Remember that that's an absolute requirement of this course. Go to your grade book. Make sure you did every secret word quiz. If there are not any that you didn't do, you got to rewatch the webinar and then send me an email with 5 pages of notes on that webinar that you didn't do the secret word quiz on, so that you don't lose 5% on your course grade per secret word quiz. So that's also really important. If you got 1 out of 1 on all of them, you don't have nothing to worry about. But if you missed any of them, okay, then you'll have to do that. Does that make sense?
Make a difference if they're.
Yeah, it makes a big difference by missing the secret word quizzes. So, and the webinars are only they're less than 2 hours, usually about an hour and a half to hour and 40 minutes. Today will be a little less actually. So it's not like it's going to take, 3 days of work to redo it. Lower and upper bound make a difference. Yes, yes. So the lower and upper bound definitely make a difference if there's statistically insignificant evidence. So for example, let's suppose I'm just gonna make something up. Let's suppose you wanted to see, hey, is the average male taller than the average female? And you did your study and you found out that the confidence interval for male minus female was between negative 0.1 inches to 14 inches. So negative 0.1 inches, that means they're pretty close to the same height. Does that make sense? And you would have to decide for your client, if they're really close to the same height, what would the client do? On the other hand, if they were, 34 inches, that means the male would be much, much taller. And decide what the client would do if that happened. Do you see? Even though you wouldn't have statistically significant evidence on that. Does that make sense? Or you may not. Yeah, so that would be an example. So do not even put together the hypothesis test and the confidence interval. Those should be completely separate parts of your project. So that's a big note. Do not think about even the same paragraph. Do not write about both of them. The only time you could write about both is in the introduction saying, we conducted a hypothesis test and did a confidence interval. That's about all. Don't say what it was or anything. You know, the point is they should be in completely separate places because they're very different things. They tell you very different things. Okay, good questions, really good questions. Okay, so again, that was a secret word quiz discussion. ANOVA, chapter 13. It's one of the easier ones, by the way. It's an easier week in terms of the regular assignments because project 2 is a tough one. So ANOVA is also due Sunday. And then I want to mention, because it's important, there is a final exam. Okay. By the way, if there's a white with a slash, that means that you don't get to see these anyway. I got rid of them. And the main thing is for the final exam, it's due March 27th. Okay. March 27th is 1 week from tomorrow. It is actually the only thing in the entire course that's due on a Wednesday. I didn't want the final exam due this Sunday because next week's finals week. But the course is over, not on a Sunday. It's over in the middle of the week, so I made it Wednesday. Yes. Now, when it's due on the 27th, you could do it on the 26th if you want, or the 25th. But don't wait till the 28th because that's too late. It's over. Does that make sense? You're used to doing things on Sunday. Do not wait till a week from Sunday to do the final because you're not allowed to. I'll have already submitted your grades to the college.
It's like you can't lose the crowd.
Does that make sense? Yeah, so the final exam is, due next week, but that means the last time you're allowed to do it. It's not that, but I don't want to, I mean, next Wednesday. But I want to make sure that you know that. The final exam also, unlike finals in other courses, it's not that big a percentage of your grade. Okay, it's no bigger than any of the other exams. So that's just a big note. Okay, and in fact, if you go to the syllabus, since that's the end of the last thing you have to do in the quarter. If you go to syllabus, the exams are 10% and the project's 10%. So the final exam isn't even worth more than a project. Do you see? Or any of the exams. It's just 10%. You know, it doesn't mean you shouldn't do it, but just let you know that in terms of how much it works, how much it's worth. Any questions at all? Any questions at all about anything? This is our last webinar. It's not your last chance to ask questions because you can post on the Q&A board, on the Project 2 discussion board, email, whatever. But it's your last chance. You know, it's basically going to be your last chance to ask questions in a webinar. So if you miss a secret word quiz, it means you need to go watch that recorded webinar. Take 5 pages of notes on what I wrote, what I said, and email it to me. That's the requirement. Does that make sense? And that's the rule. Yeah. Okay, and don't wait till 5 weeks from now. That's too late. So it needs to be emailed me by next Wednesday, by the way. Because that's kind of the end of the course is next Wednesday. Okay. Any other questions? Okay, why don't I'm going to stop the recording. For all of you who've been going to the webinar, thank you very much. So I'm going to stop the recording.